now? Yeah.
Great. Let's see. Yeah, so I'm from a University of Technology, but from the management school, so probably this is why I have this problem here. Even though actually I'm a physicist by training, so I'm kind of a mix, and I realize it's the same in the classroom here. So like half of you from MBA courses and half from engineering and IT. So I think it's ideal also for this paper. It's called Modularity for Value Appropriation, Drawing the Boundaries of IP, and it's joint work with Carlos Baldwin from Harvard Business School. Since you asked me to say a few more words about myself, I mentioned I did my first degree in physics, then studied, it's a complicated way, but I got a PhD in economics, then became a consultant, and after that became an assistant professor, and now 4 years ago, full professor in management. It was kind of a non-obvious career path, but a lot of fun. Otherwise, yeah, I spent some time in the US working with Eric von Hippel at MIT in 2002 and with Carlos Baldwin at Harvard Business School last year. Good. So much about me. This topic, I should say a little bit more about how we got there. Since 2001 or so, I've been doing research on open source software. Not from the technical side so much, even though I learned a lot about the technical aspects, but more from the business side. So why would, in particular, commercial firms do that? Why would they support developing open source software or even develop it in-house and then make it freely available for everyone? That's not obvious. I mean, these days we understood that pretty well, but 2001 it was pretty unclear. And at that time, there was no research on that. So since then, I've been working on that topic. And one point is companies normally don't make all of their open source developments public. They very often are selective in that. So they would reveal some parts of what they've done, and other parts they would hold back for a while or even entirely, or not give it out as the source code at all. And there's a paper on that with the title Selective Revealing in Research Policy. And if you want to reveal software selectively, well, if you have one big monolithic piece of software, you cannot do that. You cannot just chop it into pieces and say, okay, this part is going to go on the web, and the other part we're going to keep proprietary. It has to be modular. And that kind of naturally led me to Carlos Baldwin, because she's an expert on management aspects of modularity. She's written a lot of stuff on that. And apart from being a wonderful person in general, she's very knowledgeable. So we teamed up a few years ago to work on that topic. And last year, I had a sabbatical, which I spent at Harvard Business School. And then we worked on this stuff here. Good. Now, okay, probably everybody knows here where the screenshot comes from. So, namely,
Is that Counter-Strike?
That's Counter-Strike, yes. So, and what do you think? Why is Counter-Strike interesting here? I mean, we don't want to do shooting games here, but does anybody know about how Counter-Strike was developed? Good, because that's a really cool story, I think. So it was initially created by a company called Valve Software, and they created a game called Half-Life. And what they did is, Half-Life has a core engine, which they kept proprietary, and it has a complementing code, which was made publicly available, and Valve allowed modifications and allowed people to share these. So basically kind of an open source part with a proprietary complement here. And that turned out to be a huge success. What happened is users developed within, I think, 9 months or so, a modification which they termed Counter-Strike. And what Valve achieved is a distributed value creation. They didn't only develop the stuff in-house, they actually had users help them in doing that. And this modification was not just a little bit nicer colors. They turned the single-player shooter game Half-Life into a team-based multiplayer game, which is a huge advance. In terms of hours played, I think Counter-Strike is like 10 or 100 times more popular than Half-Life. But the good thing is, you need that gray part here. So Valve profits by selling the core engine for every player who wants to play Counter-Strike. You can download the mod. You can download Counter-Strike, even though it's now also commercial. But anyway, But you still need the core engine, so they appropriated value here. And this is the striking thing about this Counter-Strike example. This combination of being open, so here open innovation in the most open sense possible, really throwing out your stuff and waiting for someone to improve it. You don't even know who, but someone did actually. A lot of people did, but these guys who were particularly successful and created Counter-Strike, but still they managed to channel money back to them with this complement that you need in order to play the blue stuff. So IP modularity, which we call, sorry, I should explain the term. That thing here is modular, and in a nutshell, the modules are under different IP status. IP stands for intellectual property, so it may be patented or not, but the point here is this part is kept secret and protected by copyright, and this part is made public, so it's not kept secret. So the IP status differs. One module is proprietary, one module is open, so which is why we call that IP modularity. I want to stress the fact that the same value creation would have been possible with revealing the entire code base. However, value appropriation would then have been severely hampered. So IP modularity affects value appropriation. And an important note here to embed that into the context of modularity research, all what we know so far about modularity, that it simplifies design, production, use, whatever, all these aspects address value creation and not value appropriation. So this is an aspect of modularity which addresses value appropriation. By the way, should you have questions, please feel free to ask anytime. So, summarizing, this paper is about how to manage intellectual property rights and a system's modular structure, and in conjunction. It's not only about asking, okay, I have modules like here, your board's modules A, B, C, which IP status do I award? It's only about where to draw the boundary, where to draw the line. Should I maybe move the line over here? So decide simultaneously about the modular structure and the IP status that you award to each part. And the purpose of that is to reconcile distributed value creation and value appropriation. And this distributed value creation may mean innovation, open innovation, which is why I'm here, I guess. But it may also simply mean outsourced production. If distributed value creation means you have different suppliers who produce your stuff, then maybe you want to chop it up in such a way that they cannot understand your intellectual property from what they're doing for you. So coming back to the Valve example, what did they have to do to achieve this happy outcome, as we call it? First, they modularized the technical system. Okay, that's kind of the technical precondition. They identified the possibility for external value creation. Okay? They asserted exclusive control of the knowledge elements for an essential module, namely the engine. And they prevented exclusive control by others of knowledge elements for complementary modules, namely the blue stuff, the game. This is important because there are two other examples, which I'm sure you're familiar with, which are less happy, namely the IBM 360. And don't worry, we're going to look at the whole stuff systematically in a moment, but as a trailer, let me show you these examples. The IBM 360 was a big breakthrough. It was the first computer system that was highly modular. It allowed users to selectively upgrade and to mix and match components. So they modularized their system, but they did not really think about possibilities for external value creation. And by doing so, they kind of invited competition. Other firms couldn't really compete with IBM by selling a whole system. IBM was really dominant, but they could compete with selling only printers or only such and such devices. So here, the IBM failed. Also in asserting exclusive control of knowledge elements for an essential module. In any case, to the point that other people were really in a position to make pretty good profits on selling whatever printers or tape drives, etc. They did successfully prevent exclusive control by others of knowledge elements for complementary modules, but as you see, they don't have a green tick everywhere. And another IBM example is even more familiar, the PC. They modularized. They did identify possibilities for external value creation. In fact, they invited Intel to supply the processors and Microsoft to supply the operating system. What they did not think about, or they did, but it failed, they did not successfully assert exclusive control of knowledge elements for an essential module. As far as I know, they tried to keep the BIOS proprietary, but that was re-engineered, so tough luck. And even worse here, they could have anticipated that, we guess. They did not prevent exclusive control by others of knowledge elements for complementary modules, as we know. The thing with AMD didn't quite work out. In any case, Microsoft has exclusive control of the operating system, by and large. So these were less happy outcomes. And the concept of modularity has been criticized for these very reasons, that it would invite competition. And we say, well, yes, it depends. If you do it well, if you not just modularize technically, but if you at the same time award correct IP status to the individual elements, then again, you might be able to combine distributed value creation with value appropriation. So much for the introduction, in a way, and the overview of the topic and the main argument. Now I want to step a little bit back and show you background. What do we know about modularity and value creation? And then introduce IP modularity more systematically, discuss a number of cases and propositions, and conclude. So this is really Modularity 101. What is modularity? And we follow here the book by Baldwin and Clark, pretty thick book called Design Rules. Most systems consist of individual components. Right. Whatever these may be, think of components. And important point is components alone don't make a system a modular system. What matters is you have an internal structure in these components. Could be lines of code. And then you get between these elements here linkages. This may be function calls, whatever, or even mechanical linkages in a mechanical system. And the definition then is if the elements within each module are powerfully connected among themselves, but only weakly connected to elements in other components, then you call that a modular system. For the programming, that would mean that data transfer between modules is limited and not too much data is being transferred and not too many different variables are transferred, etc. So I think that gives an intuitive idea. In contrast, that would not be modular, where you get lots of dependencies between the elements in different modules. Or not modules, components. Good.
Joaquin?
Yeah?
If you can go back to that one, I think another interesting thing here is if you look at component 2 and 3 on your modular system on the left, there are no interactions between 2 and 3.
Yeah.
So if you were to swap one vendor of component 2 with another vendor of component 2, you wouldn't have to change anything about the design of component 3.
Absolutely.
So you have the ability to switch
Absolutely.
at very low cost.
Absolutely.
In the abstract, anyway, at no cost to the performance of the system in a modular system. Whereas on the right-hand side, if you were to swap one vendor's implementation of component 2 with another's, all those interdependencies conceivably could work differently, and the whole system may no longer function.
Exactly. Exactly. This is exactly one of the classical advantages of modularity, being able to replace modules, be it from different vendors or from a range of modules that you offer. If you buy a car, you can have different car seats because they all fit into the same place within the car. Coming actually to exactly your points, Henry, how modularity enhances value creation. There are 4 points here. The most simple one, the most basic one is a cognitive dimension, that if you want to solve a problem, then breaking it down into sub-problems which are more or less independent helps us think about something and helps us solve problems. If you bring that to a higher level of organizations, how organizations tackle problems, modularity enables division of labor, both within and between firms, both for R&D and for production. And tons of people have written lots of interesting stuff about that. Now we come to functional aspects, and that's what's important for the engineer. Modularity helps improve internal functioning, enables reuse of components, simplifies maintenance. So you can replace a broken component, or you can reuse things like the car industry does with platform products, etc. And finally, on the use side, and somewhere here, I think in the reuse or here in the selective upgrades thing, that's probably closest to what you just suggested. On the use side, you can satisfy heterogeneous demand. If you order a car, well, you just choose from a menu of things. Various engines fit into the same car body, etc. Good. We know that. But as I said, all of these things have to do with value creation, be it cognitive, organizational, functional, or on the use side. None of these dimensions says anything about who appropriates the benefit created by modularity. So, which is why we absolutely had to introduce this concept. The world was waiting for it, we think. Okay, so what is IP modularity? An artifact we say is IP modular when the modular structure imposed by intellectual property rights coincides with its design structure. And you will see an illustration in a moment that makes it more clear, hopefully. And when I say IP, usually you think of patents first, but it doesn't have to be patents. It can be copyright, it can be contracts, or it can be informal IP in the sense of secrecy or even lead time advantages, that you keep something secret for a while and then make it public. So the questions we ask is, IP-wise, so from an IP perspective, which elements must or should be treated identically or differently, or will make such differential treatment necessary in the future? Let me illustrate that. Think of this as a software program, or a billiard table, but so it's supposed to be a software program, and it has certain 3 components, or even could be technical modules if you want. But the components have elements here under different licensing terms. A, the yellow guys here, they are from some open source software under the general public license. That means, for those of you who, if anyone should not know, this license grants everyone the right to, if you get the compiled code, to receive the source code as well, to modify the code, and to distribute modified and unmodified versions. So it's a pretty open license. And B, let's assume, is code which is licensed in from a commercial supplier. And this commercial supplier does not allow you to share the source code with anyone, let alone have it modified by anyone. And C, let's assume, is code developed by the company itself, by the focal firm, and they want to share the source code but not let anybody modify it. Now you immediately see there are contradictions here. Looking in particular at the top component here, if I took that component and passed it on to someone of you, then the general public license requires that I make the source code available to you and allow you to modify it, while license B forbids to do exactly that. So I cannot give that to anyone. I can use it in-house, but that's all I can do. So here's a licensing conflict, and we call that lack of IP modularity. It's not IP modular. We have strong IP incompatibility in all components, in particular in those that contain A and B together. Now, as I said, this paper is about managing not only IP, but it's about managing IP and architecture. And this is drawn in such a way that by redefining the boundaries from here to here, by changing the architecture, you can actually create modules which are now homogeneous with respect to their IP. And I will give you a real-world example. It's not just a colorful billiard table illustration. It is that really happens. And now you can give out that module and let people play with the code and modify it. And you can keep that proprietary. And you can have people look at the source code of C but not modify it. Good. Now let me flesh that out with cases and propositions. we will look at 4 different categories of cases to structure a little bit what we see, this plethora of things. And the most important dimension is the distinction between outgoing own intellectual property, or if we talk about innovation, then that would be the outbound part of open innovation, and incoming external IP, or in the case of innovation, the inbound dimension of open innovation. In that case, that's the example of Counter-Strike. IP status of modules can be specified by the firm, Valve in that case. And here, if you're licensing in some stuff, as in the billiard table example, then we are in this world. There's the IP status of the A and B elements externally given. The second dimension along which we distinguish is if the IP status at the time of designing the artifact is certain or uncertain. You will see what that means. I'm not going to talk about the boxes here. I'm going to address them one by one. Let's start here, top left, the situation where we have outgoing own IP, and at the time of designing the artifact, the IP status is known. So you know what you would like your product to look like. That's actually the case where also the Valve, as I mentioned, the Valve Counter-Strike example fits in. But here's another example which, in a way, is even nicer because it shows that the company was willing to incur cost in order to achieve IP modularity. M Systems, does anybody know the firm? No? Anyway, good. They do flash memory. And their products, I think they were acquired by SanDisk 2 years ago. Their products are widely used in mobile handsets. And in the first generation, what happened is they put the driver together with the flash management software on the host, on the mobile phone, and had the flash controller on the flash. The problem is this flash management software contained a lot of valuable IP. So there were protocols and stuff in there which they didn't want to make public because then other firms could have imitated a lot of what their product really made valuable. So that had to be kept proprietary, this driver here. The problem is that meant to forego opportunities for distributed value creation, in particular since this device here and the driver were used more and more with Linux. In the Linux world, I mean, as you may know, in embedded systems, it is anyway very important to have access to the source code, more than in desktop computing. But especially when you have open source operating systems, then people are really used to that, used to having the source code. And beyond ideology, it just creates very real engineering advantages. So people were asking for the driver with source code. Now they had the problem that they wanted to keep the flash management software proprietary, and what they did is they refactored the software. They really changed not only the IP status, they changed the architecture of the artifact. They cut this driver in pieces, so left a thin driver on the host and moved the flash management software, which they wanted to protect, onto the device. And now the thin driver could be made open source, opening up opportunities for distributed value creation, because all these mobile phone makers could now fit that into their system and trace bugs into the driver, even if the driver is okay. Sometimes you want to trace bugs into the driver. So as in the case of Counter-Strike, they managed to have the color is exactly the opposite, but they have this open part here, which allowed distributed value creation, and the proprietary part here, which is complementary, which is essential, and that no other company could assert essential exclusive control here. So they fulfilled all these conditions that I presented earlier and had the best of both worlds, the open part and the proprietary part. Now, to make that very clear, the other reasons why you would modularize something did not apply. So they did not do this in order to achieve engineering advantages like improve functioning or distribute R&D or enable reuse or simplify maintenance, nor did they do it to improve the use. So for example, heterogeneous needs by being able to replace one module with another, or flexibility for changes. It was not about these things. It was really about what I just explained, being able to allow distributed value creation here while securing appropriation with the proprietary part. And Kaplan, the CTO of that firm, put it very nicely. He said, in an effort to keep their highly sensitive competitive IP protected, flash vendors would insist on non-disclosure and licensing agreements. So they would sometimes give out the source code, but in a restricted way. For Linux and other open source platform developers, this simply would not do. Second generation introduced a new architecture. With sensitive IP now embedded in the storage device, flash vendors no longer need to worry about exposing competitive secrets. And we could add here the guys who were using it, who were embedding that into their systems, could benefit from the openness of the driver. Yeah, I said that. Good. Now here are a few more examples to make really clear this is not a software-only thing, even though for software it is easier than for tangible things to redesign the architecture. That's pretty clear. But so if you take a car, you cannot easily say, I'm going to cut the door differently. But you can do some things. In any case, you can, given a certain modular structure, you can decide about treating different modules differently IP-wise. And here's an example. Korean shipbuilders, for example, they would outsource non-IP sensitive modules to China and do the IP sensitive things themselves. And actually, the lead example that we have in the paper, which I'm actually not talking about in the slides here, is porcelain production in Saxony in the 18th century. Because at that time, European kings and counts, they spent fortunes, literally fortunes, on porcelain from Japan and China. And they also spent a lot of money on trying to re-engineer that stuff. And there's a wonderful book, it's called The Arcanum, about one guy named Böttger who finally managed to solve that problem. And when he was about to die, they wanted to protect the secret because he was the only guy knowing how to do that, who really understood the whole process. So when he was close to death, the king ordered him to tell his secrets to different people. One knew only how to make the paste for the stuff, and the other how to do the glazing. So that if one ran away, they would still not have, he would lose a part of the secret. That's also tricky. But he couldn't take the whole secret with him. It's a wonderful book. It's a historical account, but it reads like a novel. Anyway, so just to make the point, it is certainly prevalent in software, but it happens beyond software. Another example that I had an interesting lead, but then in the end, the company turned out to be too secretive, so they couldn't get more details. A US maker of batteries, they have a very clever architecture of the battery, which increases capacity a lot. And they outsourced production in such a way that, again, the various suppliers could not, from what they were doing, understand the whole thing. That's pretty similar to the porcelain example. And they did the architecture in such a way that they could chop it up into pieces such that each single piece just did not allow to understand how to make the whole battery. Now in the paper we have 10 propositions in order to summarize what we think are important insights about IP modularity. Let me tell them to you, even though I'm not going to go into detail for all 6 of them, and 10 in total. The first is pretty clear. The greater the potential for value co-creation in the surrounding ecosystem, the more advantageous is outgrowing IP modularity. Because as we saw, if you completely take this potential, if you completely use that potential, there might be an issue with value appropriation. So the more you want to take advantage of that, the more advisable it is to modularize IP-wise. Now, there may be great potential for value co-creation, but from only one partner. In that case, you can probably get along with contracts or even with relational contracts and trust. But the more distributed, numerous, and anonymous the co-creators of value, again, the more advantageous is IP modularization. Think of the example of Valve and Counter-Strike. The company didn't even know who was possibly willing to work on that stuff. In theory, you could write a non-disclosure agreement with every collaborator, but I mean, that's not what programmers like to do. They like to hack on stuff and not write legal documents or sign them. The more complex the downstream system, again, the more advantageous is outgoing IP modularity, because here we assume that if it's pretty complex, then having access to what you get from upstream or having an understanding of the inner workings is more important. But again, if you give people the chance to understand the inner workings completely, then you may give away too much of your knowledge. The greater and more varied the need for downstream adaptations, again, I think that makes sense. When the focal firm shares a common supplier with competitors, because then there might be a leakage of knowledge. So you only want to share with a supplier what really needs to be shared. And finally, when the focal firm intends to outsource development or production, but its IP is not strongly appropriable. Again, then you want to, like with the Korean shipbuilders, you want to divide and rule. So give some parts only to some people and other parts to someone else. Apologies for the grammar in number 5 and 6. They don't fit together with the bottom line, but this way I could put them all on one slide. So that was the upper left box. Here's a question.
Sorry, could you illustrate a little bit more why number 5 is the case? And in number 2, why anonymity stimulates the co-creation? Because I think sometimes acknowledgements kind of incentivize you to participate in the co-creation process.
You said acknowledgements that kind of you get a reputational advantage?
Right.
Yeah. Well, if that's the case, then if you go for that, then you may not need that. But I mean, firms usually they benefit sometimes from reputational advantages, but I think it's more on the individual level. But when you share a common supplier with competitors, then if you reveal all of what you're doing to the supplier, so the supplier understands you better, then that may be too much because that knowledge might leak over. So you really want to encapsulate what you do not want your supplier to know from what he absolutely needs to know. That's the idea. Mm-hmm. Other questions? Thank you.
So the technology that the supplier or the co-creator creates, is there a requirement on whether that would be proprietary technology or open source technology that they would be creating in terms of how you interact with your competitors?
Mm-hmm. Well, sometimes you probably cannot avoid that your co-creators have something exclusive and proprietary for themselves. I mean, proprietary and exclusive are not the same. It may be, for example, think of games. If someone is developing a proprietary game for your platform, but if it's not the only one, then they are not exclusive suppliers of the game. But the question is if you become dependent on this supplier of the complement. If you have a choice, you would like to keep one part monopolistic for yourself, where you have exclusive control, and the other parts should ideally not be exclusively controlled. You sometimes may not be able to avoid that, though.
I guess the scenario I'm trying to allude to is sometimes you have components that you can make as a modular, and you want to put it out to the, say, free software, open source market, or open source community for them to develop.
Yep.
But the problem is that anything they develop is also like open to all your competitors.
Right.
Except maybe you, because you described the problem, you know how it's going to best fit into your system versus it may be an adaptation to other people's systems.
Absolutely, yeah. So that would fit the Counter-Strike example pretty well. If other companies have access to the code of these modifications, they're still lacking the engine. And the engine has really, I mean, probably with the APIs, they can generate a similar engine, but here's probably a lot of knowledge in the high performance of that thing. So yeah, thank you. So the more specific it is, the stuff that other people can work on, the more specific it is to your stuff, the less danger there is that other firms might appropriate the stuff that's done in the open.
I
Anyway.
think a way of generalizing your point would be to say, you've really looked at this from the platform provider's point of view.
Mm-hmm.
And I think what you may be suggesting is looking at it from both points of view. There's going to be a platform provider point of view that you represented here,
Mm-hmm.
and then there's going to be the complementary supplier.
Mm-hmm.
And if that person has other alternatives for, let's say you're a game hardware manufacturer,
Yeah.
and this is a software game developer,
Mm-hmm.
you have a choice of which platforms to support, and you have a calculation of where you're going to put your resources. And so there's going to be an IP calculation on both sides.
Mm-hmm.
And so here we've looked at one side from one perspective.
Mm-hmm.
So to generalize, what about looking at it from both sides?
Right. I mean, we intentionally take that perspective because we also look at the architecture. And assuming you do the platform, you get the opportunity to make the platform decisions. How does it look like? Where's the boundary between the proprietary and the open part? But then, of course, yeah, the other people do their optimization as well. So if they want to supply for that, or if what they supply can be used with other complements.
Well, I mean, a specific example would be a lot of people that are making storage network equipment
Mm-hmm.
and people that are making communications networking equipment
Mm-hmm.
differ on how much intelligence should be where in the entire communication
Yeah.
structure.
Yeah.
And so there's actually a battle, an architectural battle over
Mhm.
how much value added and how much proprietary is going to be claimed by each part in this system.
Mhm.
And so that's a case where the architecture is up for grabs, if you will, at a meta level.
Oh, yeah. Yeah.
So that here it's, the platform maker gets to move first and create the architecture, and
Mhm.
everybody else responds. And that is certainly worth studying. But there's a more general
Yeah.
competition where the architecture itself is in play,
Yep.
and all the parties involved have IP considerations on all sides
Yeah.
of it.
I mean, it's just like, the architecture here is also open. I mean, this is up to the firms to decide. And this is what they do in this storage and network situation that you described. It adds competition between architecture designers, right? But you just say there's a competition between various firms with various architectures, which is what we do not look at here, or only implicitly in these propositions here. Okay, let me go to this box up here, where again we look at outgoing own IP, but at a point in time where when you design the artifact, you're not so sure about what the optimal architecture is. So you want to keep some option value. For completeness, want to briefly show the proposition, but skip an example. I do have an example in the paper, and I will also have it in the backup, but I would like to skip it for reasons of timing. But the idea is basically that you might want to make an overly modular architecture to create options for future, to capture value in the future by selectively adapting the IP status of individual modules. The idea being that if you own the whole thing, you can relatively quickly change the IP status. You can say, okay, that part of software becomes open source. That's easy. In contrast, changing the architecture and saying, okay, no, this monolithic piece is going to be chopped up into 3 individual modules is way harder. So if you anticipate that maybe in the future you want to open source or more generally change the IP status of a particular part, then you better modularize it ex ante, even though you initially may not use that option. And such flexibility is more valuable in the presence of high market or technological uncertainty. Bottom left. Now we talk about incoming IP, which I haven't talked about very much before, but that's also very important because, in electronics, software, telecom, everybody licenses to everybody else. So everybody is using incoming IP. And the problem is they might be hold up. You may become too dependent on people. And again, that's a situation where you want to think about architecture and IP. Here's a wonderful example. It's from a master thesis by Matt Lamantia, which is now with co-authors, has been turned into a nice paper. And he studied a software company that used licensed-in components in its platform. And they were spread throughout the platform, a little bit really here and there, as you will see on the next slide. The problem then was risk of holdup by the licensor on expiry of the license. So on expiry, the guy might have, with whatever pretext, increased the license fee tenfold, and, well, they would have been captive because at short notice they couldn't have changed that. So what they did in time, so starting much earlier, they redesigned the platform in such a way that the licensed components were actually segregated in a separate module. So they made it IP modular, just like the billiard table example I showed you, pretty much exactly like this illustration. And no other parts of the platform depend on the licensed code. And that's what it looks like. Isn't this beautiful? So what is that? These matrices show, it's actually quite simple. They show all the platform components. So every line here, and there may be, I don't know how many, 200 or so, every line here stands for one component. And the same components come here as columns. And a little black dot here, for example, this one here, means that this component here depends on this one. The line component depends on the column component. And as you see, there's a little bit of black dots basically everywhere. Well, here's not very much, but not much here, but a little bit is there all over the place. After redesigning the software, as you see, there's nothing here. And these are the components here from the licensed server components, and same here. So the focal firm's own components did not call upon these guys here, and they were nicely bundled into one IP module. So they this way helped, this way were able to mitigate this risk of holdup.
So my intuition kind of tells me that as you get more modularity, inefficiencies will go down, efficiencies will go down. Do you worry about efficiencies and then other people competing with you making a whole package that might be better?
Yeah.
Macintosh.
Absolutely. You're absolutely right. There's always a trade-off. There's cost of modularity, and there may be performance loss. And I guess in the example of M systems that I showed, that's probably marginal performance loss by splitting up the driver and putting the flash management software onto the flash. Yes, the non-modular, the integral systems are sometimes better. And if you really know what you want and you want to fix that and optimize its performance, then very often you end up with a highly integral system. Absolutely right. There's always a trade-off. Modularity is also more costly to develop ex ante. Developing a modular system requires much more thinking about the interfaces, etc., than to develop an integral system. So there's a trade-off, absolutely. But it seems like at least M systems consider the trade-off to be really in favor of being IP modular. Good. We have two propositions for that case here of incoming IP and certainty. The first one refers to the example I just showed, the risk of holdup. Incoming IP modularity is advantageous when the focal firm faces the risk of holdup from suppliers of incoming IP. So you want to reduce your switching cost by separating this IP module from other modules to be able to switch more easily, because switching cost determines your willingness to pay for a possibly increased license fee. The other one here draws on an example from when Sun open sourced its Java implementation. We have a wonderful quote where they said they had to go through millions of lines of code and see for, well, more or less every line of code where the IP comes from. And if they had the right to open source that, and if not, either obtain the right or, well, put it into some other, or replace the code by own code, etc., or put it in a separate module, etc. And this entanglement can also be avoided by making it IP modular from the outset, because you then, in the ideal case, you get for each type of license, you get one module or one bunch of modules. And the proposition then says incoming IP modularity is advantageous when the focal firm obtains incoming IP on different terms from diverse sources. Even if they are not opportunistic, like here with the hold-up situation, even if not, you may be just entangled with a variety of IP and of licensing conditions. Finally, here's another one of my research streams comes here, inadvertent infringement. If you talk about incoming IP, so you use someone else's IP, but you don't know really what. So you may be infringing on a patent or on some copyright without knowing it. And the example here is, it's particularly bad in the case of companies that exploit such inadvertent infringement purposefully. These guys have been called, well, patent trolls or patent sharks or non-practicing entities, which is a more neutral term, because troll and shark are both kind of evil or these dangerous creatures. The problem with non-practicing entity is that also technology supplier who sells technology ex ante is also a non-practicing entity, while these guys, they deliberately go after infringement once it happens, and when the infringer is in a difficult position to stop infringing. So, and that is particularly pronounced, that problem here in the field of ICT, because standards are getting more and more complex, and products anyway, even without standards, are very complex and contain many, many individually patented inventions. So there are uncertainties. Are there unknown relevant patents? And if so, is there a risk of patent troll, patent shark firms exploiting these infringements? Here's an illustration. Think of some artifact, and there's some problem with an infringement of some IP right. Be it copyright, as you remember the case of SCO, here, SCO, Santa Cruz Operations, and they sued the whole Linux community and IBM for copyright infringement. It was a complete disaster for the firm, for SCO in the end. But anyway, they claimed that there was a copyright infringement within Linux code, and it may also be patent infringement. Patent infringement is actually harder to avoid because you may just reinvent something and not know that it's patented. Copyright infringement actually can only happen when you really steal someone else's code, but it may happen that someone else stole the code and sold it to you. Anyway, if you've got a monolithic or integral product and there's a legal problem here, it concerns the whole artifact. And click, click. If the artifact is broken down into modules, well then, if the problem is up here, then you can replace or maybe even drop this module to get rid of the problem. And so summarizing, IP modularization mitigates that problem by creating option value. Even if you don't know yet that there's a problem here, if it's broken up into little pieces, then you are able to replace things. So modules that turn out to be shark infested can possibly be dropped or replaced. Ex ante, you can group potentially risky functions together. And a very nice example is the MPEG video compression standard. One of my colleagues in electrical engineering, he is working on the standardization committee. And he says that is a real issue for adoption of that standard, that people don't really know if once it's really widely adopted, some company comes up and says, look, we got a patent here, and you pay us. You may know of Forgent. Anybody knows the example of Forgent? It's a company, they kind of discovered that, oh, oops, look, they acquired some firm, and with the firm they acquired a patent that, I think they were into financial trouble, I guess. They looked at that and said, that could read on the JPEG standard for picture compression. And it turned out to be the case. So they collected, within 1 or 2 years, like $100 million. And I think over time they collected more, just from saying, look, we found this old patent here on the attic. There's a book, Rembrandt's on the Attic, that refers to these things. And they quickly collected a lot of money. find it fair or unfair, never mind, it's legal, this is how it's done. And the same thing might happen for MPEG or for other things. And modularization, even modularization that looks excessive ex ante, might help you to mitigate that. So summarizing, an architecture characterized by incoming IP modularity is a partial defense against unanticipated IP claims because it allows to design around the claims without redesigning the whole system. Good. Questions so far? Otherwise, I discuss and conclude the whole thing. Good. We have time for Q&A at the end, of course. So consequences of modularity. Modularity allows for distributed value creation. This is kind of open innovation, outsourced production, etc. But it may have undesired consequences. As we saw for the IBM 360, for the IBM PC, the focal firm may lose control and hence fail to appropriate value. So really strategic challenge is to appropriate value in a modular system and to reconcile that with value appropriation. IP modularity helps to avoid such loss of control and so by doing so reconciles distributed value creation and value capture. And it's obtained by managing architecture, so the module boundaries, and the IP status of the modules jointly. Scope conditions. When does it apply? In what industries does it apply? It applies to complex products and processes which have many individual components. When you think of pharmaceuticals, so I mean, what I've been talking about here mostly, like electronics, software, telecom, also mechanical engineering, these are so-called complex technologies in the sense of every product consisting of many individual inventions. Pharmaceuticals, when you get a new chemical entity, it's like a molecule. It's like one big molecule, but it's not really modular in the sense, even though you may have a group of OH somewhere or something, but these are not individually patentable. It's the whole molecule as one thing. That's called a discrete technology. So it certainly applies to complex products and processes more than to discrete ones. Second, the components are complementary. So for the overall system to work, you need both, and they work together. And then, as we saw in the case of Counter-Strike, if you protect one, then you can open up the other and allow distributed value creation there. So the system needs several components. Some are essential, some are not. And the essential ones you want to keep your hand on. And finally, designers have some degree of choice in dividing up components and defining module boundaries, some architectural freedom. Otherwise, it boils down to a problem of allocating the right IP status. But as I said, in the more general fashion, it has to do with designing architecture and the IP status simultaneously. Okay, concluding, IP defines its own independent dimension of product modularity. It applies, and I've been talking about mainly products here, but also to processes, think of the porcelain thing, but also to organizations. There's, at the end of the paper, a little bit about that. It informs established theory of modularity with an interesting point. Modularity refers very much to coupling, strong coupling or loose coupling, but nobody has thought about antagonistic coupling, because that is really what comes in here, that some parts may not couple strongly or weakly, but really be repulsive to each other. IP modularity allows to resolve conflicts between value co-creation and value capture, and also to avoid hold-up arising from incoming IP. We argue, like everybody does, I mean, that your own research is getting more and more important. Fair enough, but we really think it is for two reasons. Open and semi-open innovation processes matter more. But kind of ironically, IP is at the same time getting increasingly important, at least if you count the number of patents and the number of infringement suits. And finally, it is an issue certainly for the engineers, because they have to implement that, but also for strategy to complement that engineering thinking and to say, okay, what do we want? Because it affects value appropriation and even the whole business model of the firm. I mean, Valve, they wouldn't earn 50% of the money, or probably not even 20% of the money they're earning now without this openness, without harnessing the power of their user base. And it's of a long-term nature, because you cannot easily change your product architecture every day. So you really have to think about that in advance. Thank you. Questions?
While they're warming up, one of our first presenter this term was Joel West, talking about distinctions between user innovation and open innovation.
Mm-hmm.
And one of the distinctions that emerged from that was the presence or absence of a business model. So if you look at Eric von Hippel's work in 2005, Democratizing Innovation, the word business model is nowhere to be found in the book, because users freely reveal because they benefit directly from their own use. They don't have to worry about value appropriation in a business or financial sense because they're doing it for their own personal reasons as users. Your research to me strikes me as one that is arguing that in fact value appropriation in business models are very much issues, but it seems like you're pitching your work more in user innovation than in open innovation. I'm curious as to how you think about that.
Good point. I mean, the business model here is that of the focal firm, while the users, in the case of Counter-Strike, are those guys who do the open innovation part.
Well, what Eric would call the user innovation part.
Right, but these guys don't have a business model, as you said, in accordance with what Joel did.
Eric's story, is that the users don't need a business model.
Right,
They're doing it for themselves.
and it fits with Joel's story then very well. Even though I'm not sure if it's always the case, because I mean, users don't have to be the prototypical hobbyists. Users may well be firms who have their business model. They just realize that if we improve something that we are using and we make it publicly available, then our supplier will improve the machines and we get better machines. There's a business model there. They just accept that maybe their competitors also get these improved machines. It's not maybe the business model itself. I don't know, the term business model is also sometimes overstretched a little bit. Is it a business model when I'm doing something a certain way or not? But it may well have a business reason when, there's actually a paper by Dietmar Hauff, Eric, and myself in Research Policy 2003, why commercial firms would do that, reveal a user innovation to their supplier, accepting the fact that their competitors get it as well, but with a certain specificity to their own needs, it actually fits their business needs better. Call that a business model or not, but it's not the typical hobbyist. So I don't see such a strong contrast, even though in my story, these typical users that would freely reveal, they are not the focal firm that we look at here. Yeah?
In firms, who would be the person promoting IP modularity in terms of whose role is it to promote this software? Is it a person at a product management level, or
Yeah.
an engineer? Is it a strategist? Who would be pushing forward?
Yeah, good question. Good question. Whoever understands this interplay of value appropriation and distributed value creation. Firms, and I guess you've heard that before in this course here, firms are often incredibly reluctant to open up. So the very idea of making some of their IP publicly available for some firms sounds like crazy. There's an example, Cisco had the so-called Cisco Enterprise Printing System. So some software that managed printing across the Cisco firm network. And at one point, they made this software open source. And Eric Raymond writes about it in his book. And I followed up on that, and I interviewed these guys. And they told me that even though they had the blessing from the firm, not everybody knew. And the corporate lawyers just shouted at them because they couldn't believe that they made this stuff publicly available because they paid some money to develop it. On the other hand, when you think about that, printing management software is not a competitive advantage for Cisco. It's just infrastructure stuff. It has to be there. So they didn't really lose anything by making that public. In contrast, they really gained by getting support from outside. So first of all, people are very often extremely reluctant to open up. So someone needs to champion that idea. And I don't know, it's someone with a certain understanding for various fields, for the market and for the technology, because then you see the opportunities of, on the one hand, harnessing distributed value creation, on the other hand, dividing your product in such a way that you protect the stuff that needs to be protected.
There has been some interesting cases like device where they put out this module for
Mhm.
people to do good user, user preference prediction.
Yes.
Now, how does that kind of appropriation of IP fit under your framework? Is it really, outgoing or incoming, or like, how do you judge the certainty level there?
It's outgoing because initially Netflix put out an existing algorithm, and then other people improved it. It's little bit like Valve putting out the blue code, the left-hand part, the blue code of Half-Life. But the complementarity here is not with another module of one system, but it's more with what Netflix does. So Netflix can use that software better than anybody else can. So has kind of an analogous thing to exclusive control over something to which this improved code is complementary. But it's not like one artifact of homogeneous type that is split up into pieces. That's the difference.
Okay.
Thank you. Yeah?
In terms of modularity, I mean, SAP is a huge system that
Yeah.
has different modules, but how do you ensure the consistency? Because it's often the complaint that it's growing too fast and it grows
Yeah.
differently in one module, but it's not consistent with the other one, even if it integrates, but it's kind of different. And how do you ensure consistency?
Good question. I mean, it's a general question about modularity, right? Not about really IP modularity. And it goes into the same direction as your question about what about performance losses when you modularize. I think you don't have an alternative, really, because if it's a non-modular system, imagine SAP would be non-modular, and then people would fiddle around with individual parts of the system. That would be an entire disaster. So I think you have to go modular, and then ensuring consistency, well, it's a constant challenge, I guess. But what else would you do?
Is it like a team working among all this? Or, I don't know.
Well, the thing is, if in a modular system, what you have is you have the interfaces, and they define what comes out of a module, what goes in, and you get information hiding. The information within a module is hidden from the other modules. And that stuff you are allowed to modify as you wish, as long as you maintain consistency of the interfaces. Now, the problem comes up when not only the modules internally are modified, but when the overall architecture is modified, because then this independence between modules is given up for, at least for a while, until you have restructured the whole system, introduced new interfaces, etc. And since a huge complex system like SAP cannot remain stable all the time, that creates these problems, I guess. But I don't have a quick answer how to avoid it. Just be very, very careful.
Actually, a couple of points. What are the key drivers that are pushing companies to modularize IP? Is it because everyone else is doing it? Or is it kind of pointing to a second question, because companies are becoming more global, they're having to modularize different aspects for when their businesses move into another territory where IP might be completely different? I was thinking your background from Europe versus the US. How does IP modularization translate between countries?
Good point. I don't think there's a big difference between Europe and the US in that respect. But if you go to countries with a really weak IP regime, then we have an interesting example from Mingyuan Zhao from Michigan. She's from China, and she wrote a PhD thesis and a management science paper about how companies would split up organizationally. They would do some of their R&D work in weak IP countries, but due to strong complementarity to in-house R&D in the home country, they would be able to do that. So kind of distributed value creation in the sense of having R&D work done in China, but due to complementarity with what they did at home, and the fact that they maintained exclusive control on that part allowed value appropriation nonetheless. So here comes the country thing comes in. The other thing, if it has to do with globalization, only in that respect. But I think the main driver is for me that companies more and more understand that there's some benefit of open innovation really in the sense of going, like of open source open. So I mean, if you license with one firm, that's also open innovation, but it's under control due to a contract, and you know who your partner is. But if you just throw out stuff on the web, hoping for someone else to improve it, then this is more open. And companies are slowly understanding the benefits of that and really and practice. Some companies are very good and others are just learning. And to the extent that you understand that, you have to think carefully about architecture. So I think it's more that driver than globalization, even though in some examples, globalization requires that as well. Yep.
Would you say overly modular architecture is a good thing for disruptive technologies?
Can you define disruptive for me? Is it really the strict Christendom sense, in the sense of...
It's difficult to predict how it's going to be taken in the market.
I don't... My feeling would be no, because you see, when we talk about architecture, we talk about complex systems where the overall system creates the value. I mean, while disruptive technologies are usually not part of one well-defined system, they're kind of something really new coming along. Or not really new. Well, it depends. The term disruptive has been... Christensen had it nicely defined, and then the whole world uses it synonymous with radical. And it seems to me like you're using it in the same, more radical sense. Is that right?
Well, I suppose if you just look at a mobile phone or something like that, it's
Yeah.
having been disruptive. Is that something that's very modular, or?
I don't necessarily see connection there, because disruptive may be something in pharmaceuticals as well, when you realize that instead of taking some expensive antibiotics, just whatever, chewing on paper is nearly as good, then this is kind of certainly disruptive for the pharmaceutical industry, but there's nothing said about modularity here, I think. Well, seems like we finished early.
I think we did.
Let me thank you very much for your questions and comments. They're very helpful.